qualitative data. The categorical data types are also divided into two. We have nominal and ordinal. And when we look at nominal, these are the categorical data types which are not ordered, are not arranged in ordered form. They don't need any order or any sequencing. Example, when we talk about religion or when we talk about facility ownership, the categories can be arranged anyhow without following any order. In contrast to ordinal, the ordinal categorical or data type, they are the ones which they require a particular order. Example, disease severity, or when you're dealing with linear scales, low, middle, and high. So there is a particular order that should be followed. The other type, the numerical one or quantitative, it's also divided into either discrete or continuous. Discrete are usually counts, or we call them whole numbers. Example, the number of malaria cases. While continuous, these are measured values. They include like height, temperature, and you can give more examples in that order. All the continuous, other they say those which have decimal points, they call them as continuous data types. So quick example here, we have lab test results or parasite density. Let us do this together, and you can either unmute yourself or you can put it in chat box quickly. The lab test results are which type of data type?
Any volunteers? Either online also or in the room, if you know the answer.
Is a continuous data.
Yeah, continuous data. Yeah,
it's continuous.
Thanks, Babalalo. Is it Babalalo? Yeah, Babalalo. Babalola. My apologies. Yeah, and facility level malaria counts, please, anyone? Malaria counts, these are counts.
I think it's discrete.
It's what?
Discrete.
Yeah, it's discrete. Thank you very much. And the patient satisfaction survey? Patient satisfaction survey, it's a satisfaction survey.
I don't know if I'm correct, but that should be ordinal. Is that?
Yeah. Thank you very much. That's ordinal. Because it's a satisfaction survey, either this person, you can easily measure it in low, middle, or high. So we have this a quick exercise to cement our understanding in data types. And I've taken it a little bit quickly because we already introduced it in the first time in the data management workshop. So please read the question and I'll take you through. So a data set contains a variable called facility type, coded as 1, 2, 3, 4, and 99. And the meaning of the codes is hospital, health center, dispensary, clinic, and unknown. A student calculates the mean of the facility type column and gets a result of 22.3. What data type is facility type?
Feel free to either shout out the answers or post them in the chat.
Yes, please.
As Christina walks you guys through.
Facility type should be a kind of nominal data.
No. Someone else, any different answer? Is there someone?
Kaiser said ordinal.
Kaiser said ordinal. Someone else?
Kasim said categorical.
Categorical. Okay. So the data type is, I'm rereading question. I'm rereading the option A. What data type is facility type? Explain your answer. So the facility type is categorical, and it is. Let me go back to categorical. It's categorical and it's nominal because these are categories. The facility types are categories and they are not in any ordered form. So they are categorical in nominal form. Question B, is it statistically appropriate to calculate a mean for this variable? Is it appropriate to calculate a mean for this variable?
There's an additional explanation actually from Kaiser of why he thought those were ordinal.
Yeah, that's great.
Because you can see the numbers seem to be correlated to different levels. So he was saying that the facilities are ranked.
And that
Yeah,
takes us to the second question. Thanks, Kaiser. And that will take us to the second question. Is it statistically appropriate to calculate a mean for this variable? Anyone in chat box or in the house? No, it's not. Yeah. So it's not. The numbers 1, 2, 3, 4, and 99, they are like codes. They're just codes representing the facility types. And you cannot calculate the mean in this order because the average of a dispensary will not tell you anything. Option C says, what will be the most appropriate measure of central tendency for this variable? Now, since we cannot calculate the mean, what will be the appropriate measure of central tendency for this variable? Yeah, we have not yet discussed about central tendency, but if somebody else understands what will be the appropriate measure? Mod. Thank you very much. It's mod. And what does the value 99 most likely represent, and how should it be handled before any analysis? What does 99 represent? Okay, that's a missing value. 99 is a missing value, and we'll discuss about it in the following lectures. Is there any question? Oh, when did Kasim join this quiz? So let's get into this quick quiz. It's a slider. We have a few questions just to cement on what again we've just learned. You can take your phone and scan the code. If you don't have a phone, please go into slider.com website and input that hash 56 65 63 5. Yes, thank you, Kaiser. Kaiser, yes, please.
So I had a different view on the 99. What does 99 mean?
Yeah.
So
So in
I
this,
thought it might be we have facilities, but we don't know its category, or we don't have a value at all. What do you think?
okay. It takes you back. It takes you back to the one who have developed the questionnaire. So there is a context where I have set the options like 1 to represent hospital and 4 to represent to represent clinic, and maybe 99, it can be unknown, any variable like that. It's not necessarily a missing value, or it depends again to the data dictionary what it was initially meant by 99. Are they those facilities which are not known? Or is it maybe it was a skipping questions and those who were skipped, they were hard-coded 99? So it all depends on how the questionnaire was phrased. I cannot draw a line to say it is a missing value or it's a particular facility, because it can also be a question which they're supposed either people to skip for several particular reason. So it's like that one, it's blank. However, let's go ahead and we'll meet this discussion and we'll pick it from there. Yeah, can you please scan the barcode and join into slido.com?
And when joining, if you want your responses to remain anonymous, feel free to use a nickname instead of your actual name. Yeah, sorry, the message came a bit late, but we'll have another round of a Slido question. So yeah, you can keep note of that in the future.
Okay, 1, 2, 3, 4, 5, 6. Can you proceed with 6? Yeah.
Has everyone been able to join? Okay, yeah. Proceed. Yeah, so the time is pretty short, so you may want to complete it. Yeah, I think you may want to relaunch it again. So there are 15 seconds assigned for each of the questions. And you may want to do it a little bit fast just because it is timed.
Yeah, thank you very much. So a patient sex recorded at health facility, it's categorical. Here's the second question. Great. And the last one. Done. Okay. Here we have variability of a facility ID number in the National Health Database, example facility 101, 102, which type is it? This question resembles the last question which we previously discussed. The facility ID number in the facility health database, you have facility that, facility that. Can I know who said discrete and who said nominal so that we can discuss this? Is it possible?
I don't think you can see, but you can just like talk through the responses. You can see the person.
Okay, can someone volunteer to say why they've chosen nominal? And the one who said
Hello.
yep.
I personally say this discrete, and because this are the ID you the ID of the facility. It's not yet ranking. They're not ranking yet the ID. It's just to show that this is ID number 1, ID number 2, ID number 3. But we're not ranking according to the quality of the facility, but we are only identifying that this is the given facility with this ID.
Great. Thanks, Lembris.
Hello.
Mm-hmm.
So I personally chose nominal because I think the ID in a database, the IDs are categorical, but it's just the number of categories is so that's what I think.
Hello. I also personally chose nominal because actually those numbers from the way it looks were just assigned to label or identify each facilities. So it's more of an identifier, a number that has been nominated to represent each facility. So that is why I went with nominal.
So, is there anyone with a different answer, or should we proceed? Great.
You have to share with the correct response.
Yeah, it's yeah. So a facility ID number in the National Health Database, that's nominal. The data type, it's nominal in this context. Descriptive statistics. So again, once you have collected your data, you have it and you have to start analyzing it. Now in statistics, we have two trends. We have descriptive statistics and inferential statistics. Now in descriptive statistics, it's you're trying to understand your data, you're trying to learn, to know the trends, to know the relationships, to summarize it, to find the nuances or any small relationship in your data. And in this context, we usually use the measures of central tendency and the measures of dispersion. So the measures of central tendency, these are mean, median, and mode. We're trying to look how your data is aligned at the middle, at the center. While the measures of dispersion is how your data is spread out. From the images on your right side, we can see how the mean, we can simply see the idea of how the mean is. As I said, mean is the arithmetic average, it's the average. We are looking at the average of your variables. So this is very useful. It helps you to see if your data is symmetrical or normally distributed. However, it's very prone to outliers. So if there are any outliers, they tend to pull your data to either on the upward side or the downward side. It depends with the outlier itself. So the other measure is the media. Media is the middle value. And usually you identify it after arranging your data from smallest to the highest. The advantage of media is not prone to outliers. So even if you have outliers, still media is a very good measure to help you to know how your data is distributed at the center. We also have mode. Mode, it shows frequency, how frequent your data is reported. Example, we saw this in the health facility types. Talking about the measure of dispersion, we are talking about ranges. So the range is the difference between the minimum and the maximum. And this is very important when you are summarizing your variable to understand what is the minimum value of your variable and what is the maximum value of your variable. You go ahead with that context. You reason if this maximum variable, is it right? Is it practical? What about this minimum value? We also have variance. Variance is the square of the standard deviation. And we know that the standard deviation is the average spread around the mean. The other measure is the interquartile range, and this is the 50% distribution of your data, as you can see from the icon on the right. So we also have these concepts on skewness, outliers, and kurtosis. So skewness is, we are looking on how your data is aligned. Your data, usually we expect that the data is normally distributed, but in most of the public health data, the data is asymmetrical. It can be skewed on the right or skewed on the left. And it's very important to understand if your data is either normally distributed or it's not normally. It means it's asymmetrical, because it will help you to understand which test you're going to use, which tests are specific for normal distribution, which tests are specific for asymmetrical distribution. We also have kurtosis. Kurtosis is how peak is your data. How peak does your data appear? Your data can be very peak with high kurtosis, or it can have low measures. And the other important concept is the outliers. So this is very important, how to identify outliers and how you're going to deal with outliers. Because sometimes outliers can identify an outbreak, maybe it's a referral point, or maybe it can be a wrong value, a data quality issue. So, and they tend to pull your estimates to, you might expect the mean to be a particular value, but because of outliers, it tends to pull it either upward or sometimes it can lower it. So
There's a
this,
question from Kaiser.
yeah, yes, Kaiser.
Hello.
Read the
I'm
question.
sorry. Could you repeat explaining about kurtosis? I didn't get the explanation.
Kurtosis is the measure of peakness of your distribution, how peaked your data is. Let us discuss it from here. So this is the output of the summary of test RDT under 5. So we have summarized our variable. Our variable is the test RDT under 5. We have 1,200 observations. And we can see the smallest value is 0. We can see the largest value is 702, so that it gives us the range. As I say, it's very important to understand the range. You can ask yourself, am I expecting this, that the maximum value to be 702, that the minimum value to be 0? It tells you the mean and the median. So you know that the median is 138 and the mean is 164. What does it tell you? When you get the mean is 164, median is 138. From those, yeah.
Is it like the measure of the difference between maximum and minimum?
Kaiser, can you speak a little bit closer to your mic? We can't hear you clearly.
Okay. Can you hear me now?
Yes, that's much better.
Okay. So I'm asking whether it's the same as the difference between the maximum and the minimum value, which is equal to range.
Did you hear that? I'm not sure, but when we talk about the range, is the difference between the minimum and the maximum. The range, it means you have, in our example output here, I'll say the smallest value is 0, the highest value is 702.
Can everyone see the values that Christina is referring to? Or perhaps, Christina, you can also move your cursor on the screen so that people can see.
Okay. So once you have your media and your mean, they already tell you something. You can already know from here if your data is at least in a normal distribution or it's not, it's an asymmetrical. You can see the standard deviation, it's 110. You can see the variance, you can see the skewness and kurtosis. So having the mean larger than the media, it already tells you that your data is aligned on the light. So you are not dealing with very normal distributed data. Looking at the standard deviation, these are values which are clustered around the mean. And for a normal distribution, we roughly expect a standard deviation to be a half of the mean or 1/3 of the mean. Otherwise, we also regard that data to be kind of not normally distributed. We have the variance. However, we're not going to talk much about variance in this context. It's usually used in more advanced example when you're dealing with regression and stuff. It carries a lot of, many values since it's the square of standard deviation. In this context, we mostly use standard deviation to help you inform. We also have skewness. As we said, skewness, it helps you to understand how your data is skewed. Is it skewed to the right or to the left? In a very perfect normal distribution, the skewness is 0. When we add plus or minus 5, 0.5, okay, that can be accommodated. But once you have a skewness of greater than 1, it already tells us that our data is skewed. And again, we have kurtosis. Kurtosis is how your data is peaked, the peakness of your data. The standard expectation of kurtosis is 3. Once you have about that, it shows your data is highly peaked. Now, from the right-hand side, we can see now our histogram. It's an example of our histogram. And you can see we have some of the data are aligned too much on this right-hand side. We know that our mean is around 164 and the media is 138. But our mean here has been pulled to 164, and probably it's because of these values that are extreme, up to 660 to 702. So what this tells us, it tells us the advantages of summarizing your data. You have got your data set, you summarize, you understand it. Now that I understand my data is not normally distributed, I already have idea in my head which test I'll use. Now I've visualized it, I've seen how it is spread out, and I can reason if there is these values, it's okay, or this is too much, you should question it. So overall verdict, what this output is saying, the distribution is non-normal. We have seen it's right skewed. We have seen the peak is 5. We have seen the standard deviation is 111. And in this context, you have to use the media 138 as your central tendency measure. So in these cases, you should always know, okay, which method are you going to use? Are you going to report? Are you going to report mean, or are you going to report media? So once your data is not normally distributed, you definitely not use media. You not use mean, and instead you use media. So let's look at this and let us discuss together in 2 minutes. What does this tell you? This is from a malaria study report. You have a median number of RDTs distributed per facility per quarter. What does the number 737 represent? And why was media chosen over mean? Yeah, can someone volunteer on that? So you were reading a malaria report and you found 337, interquarter range of 570 to 974. What does the number 737 represent? And why was the media chosen over mean?
If I'm correct, what that means is that the interquartile range of 570 to 974 shows that the central tendency and the spread of the data sets is indicating that the middle value, which is 50% of the data, is clustered between that range. And with 737 meaning giving us the exact middle value.
Yep. By the middle value, you mean the median?
Yes, the median, yes.
Yep, thanks. And what does you've already said about the interquartile range? What does it add to your understanding of this data? I think you said that already. Thank you. Can you describe this result in one plain sentence to a non-statistician? Okay. I'll go straight to the answer to save time. So again, as you have said, the 737 is the median, and the interquartile range is 570 to 974. So usually we do report the point estimate and the measure of spread. It's very advised not to report the point estimate itself, but to report them together. You show us the point estimate and the measure of spread. So in our case, the point estimate is the median, 737, and it tells us that our data is skewed, it's not normally distributed. But also the 50% of our data is accumulated at 570 to 974. When you go down there, the same convention applies across all summary statistics. That means when you're dealing with mean, you have also to put or to identify the point estimate, which is mean, and you have to put the standard deviation. And when you are dealing with effect size, I'm over here, you also have to put your effect size, you also have to put your confidence interval. So the main concept over here, always report a point estimate and the measure of spread. It gives much more information rather than presenting a point estimate itself. A quick example onto why we are saying this. We can take a look at District A and District B. They both have a media of 737. District A has an interquartile range of 710 to 765. So you can see how there is no variability, the 50% data accumulation as compared to District B. District B, the ranges goes from 120 to 1,840, but they both have the same media. Now, if you just report the media 737, you'll be misinforming, because if it's the distribution of resources or anything, they will think that those facilities are almost the same. However, when you look at District B, the other facilities which they go to 1,840, it's very much, it has a lot of outliers as compared to the other one. So once you present the point estimate together with the measure of spread, it gives you an understanding of how spread out your data is, and it will also help you into when you're distributing the resources or when you're doing a particular intervention. So both districts report median of 727, only the spread reveals that District B has a serious problem. Is there any question in this context? Never can you form groups?
Yes, we're going to do it in breakout sessions. Breakout rooms. We'll just do that. Witty was asking you to repeat the other slide. If we could repeat this.
While you're making the breakups. Yeah. So in this context, I'm repeating this. Thank you for raising that question. What we're trying to emphasize here is to always report the point estimate and the measure of spread. Reading a report and it only tells you that the media is 737, it's kind of misleading because you don't know, you still do not have information of how that's, how is the spread of that information, how is the spread of that data. And I gave an example of the two districts, District A and District B, which both have a media of 737. But when we look at District A, we find that it's understandable and there is no a very big variability of values as compared to District B. District B, there are values that start very low, 120 to the very highest, 184. So that means that there are some health facilities that require 1,840, while there are some health facilities that require distribution of only 120. So once you supply resources with your notion as District A, that will be misreading because District B, it already shows that they have a serious problem. Just looking onto the facilities, that some of them requires 1,840, while others requires 120. So the concept is to present your findings, include both the point estimate and also the spread of your data. Have you? Okay. So let us quick jump into this quiz to cement on what we have just discussed. You will do it in a groups of 2 in breakout sessions. I think Nema is doing that right now.
How much time?
5 minutes.
Okay. Okay, you should all be receiving a notification to join breakout rooms.
And us in the house, I think we should also divide into 2. I would like to hear your answers too.
Oh, but what's in there? Oh, because you don't. Okay. We've posted the slide on the chat for the question, so you can reference that.
So we're back. To those who are online, apologies. The question didn't show up on time. However, we can discuss this question together quickly onto those in-house that have already done the question. So the table below shows monthly malaria case counts across 12 health facilities in a coastal district over the last quarter. And we have our values there. The district health officer asked for one number that represents the typical facility burden.
Hey, I'm sorry to see you.
Yep.
I can't see the screen. I don't know whether this is from my phone or this phone.
You
If
cannot
you're
see.
sharing a screen,
Why is he not seeing this? Can you see the screen? Have you joined?
Yes.
Try it and delete and then share it again.
Okay. Thanks, guys. Let me escape. And what's happening?
mine I can see.
Okay. So, okay, the question is, the district health officer asked for one number that represents the typical facility burden to include in a quarterly report. The first question is to calculate the mean and media, which is higher and why. So to those in-house, what is the mean?
44.42.
44 point,
42.
and the media? The media is what?
20.5.
5.
20.5.
20.5.
20.5. Thank you. The second question, okay, the question still asks, which is higher and why? We see that the media is higher. Why is it higher?
It is because there is a positive skewness
Thank you.
due to the 310.
Thank you. So which would you report as a typical facility burden, and what would you do about the facility with 310 cases? So what is our burden? Which measure will you report? Will you give to this district officer the mean or the median? I'm going back in down.
I will choose to report the median.
We report the median. And why would you what would you do about first? Why are we reporting the median instead of the mean? It takes us back to our last example, because if we report the mean, we have seen already that the mean has been affected by this outlier 310. So it's not the right representative in this case. We have to report the media, as he has said. And what would you do to the facility with 310 cases?
First, we are going to cross-check,
Yeah.
like, is this a figure 350, 310 as, is it, or is it a typing error?
Yeah. Thank you. Thank you very much. We're going to go back and cross-check the 310 cases. So a colleague argues we should just remove the 310. It's an outlier. So you went and checked and found it's an outlier. How would you respond? Are we going to remove the 310 to make our life easier?
No, we should not remove it, but we have to cross-check if it is an error or a correct value to verify.
Yeah, thank you, Victor. So we're not advisable to be deleting or removing values, observations in our data set. You just have to go back and check. It can be an outbreak. It can be either an outlier, as it has been said. It can be a data quality issue or a real problem, or maybe it's a facility, a referral facility. So most of the cases have been taken there. So it can be all of those. It's a list of it can be's, it can be's. We are not advisable to delete the values. Is there any question? Yeah, so we'll give a 5 minutes break before we come back and jump into interpreting basic data visualization. So let's give a 5 minute break. If you have a question, you can throw it in the chat box while you take a glass of water. Your screen sharing is paused. Did you pause me? Can you see? Yeah, so welcome back. Into interpreting basic data visualizations. So public health professionals, usually they work with very large data sets, and they're very hard to interpret in the form of table. So you have to take it and you have to take it back and visualize it in order to easily learn and identify any patterns, any trends, any relationship and forth. In this context, we use data visualization, which helps us to compare disease burdens, to detect trends, but also to communicate findings more clearly to decision makers. But again, using a data visualization tool, it's one thing, but the question is, which tool should you use in which context? So when you're dealing with distribution of continuous data, like how we previously saw, you will easily use histogram or density plot. And when you want to see the media spread and in case of identifying outliers, you'll use a box plot. And the bar chart is a very good tool that helps you to see or to visualize counts and proportions by categories, by groups. We use scatter plots to identify if there are any relationship between two continuous variables. And mostly when you're looking your data over time, you use a line chart. And proportion of a wool, you'll use a pie chart to better understand your data distribution. In our context, we are going to look on to three tools: the histogram, the bar chart, and the box plot. So further information about data visualization, you will learn them in other workshop strictly on data visualization. As you have previously seen, the histogram helps us, it shows us the distribution of continuous variables, and you can see if your data is symmetrical or asymmetrical, if it is skewed, if it is bimodal. So histogram gives you all that picture. So you're going to use it before calculating any summary statistics. You always have to go back and investigate how your data is distributed.
What does bimodal mean?
So bimodal means your data has picked up, it has gone down, it has picked up again. You get the concept? Thank you. So the other tool is box plots, and box plot is it's a very good tool to look and identify if you have any outliers, to see the media, to see the ranges of your data. It tells you a lot, and the fact that you can compare between different categories, it's also a cherry on top. So a box plot, it's a very good tool, and you're using it to compare the same variable across two or more groups. Example, in our context, we have the test under 5 and test over 5. So we can see the line here is the media. We can see that 50% interquartile range. And we can see this test over 5, its IQR, it's a little bit wider as compared to this one. From the whiskers here, we can see the above 25%, the 25% hit the other side. We still can see that this side, it's a little bit more wide as compared to this. And we also have the outliers over here. So a box plot gives you a very good picture of the distribution of your data and in categories. And we also have a bar chart. It shows the the distribution in counts, the proportion for each category. Now you're using it when comparing discrete categories, example, malaria cases by district, or RDT used by facility, and those cases. So let's pass through this question just to make sure we understand the point. You have malaria RDT positivity rate for 120 health facilities across 5 districts in Tanzania. Your supervisor asks you to produce one chart that shows how RDT positivity compares across 5 districts, including whether any district has unusual high or low outlier facility. So which chart type do you choose? Will you choose a bar chart of mean RDT positivity by district? Will you choose a box plot of RDT positivity by district? A histogram or a bar chart of median RDT positivity by district? So you can note that A and D, they're both bar charts, but one is by mean and the other one is by median. So which chart type do you choose?
Feel free to also paste your responses in the chat.
Anyone?
Babalola says box plot for him.
For me, box plot we do.
Thanks, Babalola. Anybody else?
For me, I think I'll go with bar chart. A, number A.
Okay, bar chart of the mean. Annabelle also says bar chart of mean RDT positivity per district. David says box plot. Victor also opts for a box plot.
Okay. I think we can pick up from there. So I will repeat the question. So you have the malaria RDT positivity rate for 120 health facilities across 5 districts in Tanzania. So you already have 5 groups, 5 districts. Your supervisor asks you to produce one chart that shows how RDT positivity compares across the 5 districts, including whether any district has unusually high or low outlier facilities. So we can also see this keyword, which is advantageous in one chart, but it's not possible in the other chart, the outlier. So the chart that will give us this outlier is the box plot of RDT positivity by district. In this context, it's B. But again, when we go back to bar chart of mean and median, there is a very important concept that I want us to understand. What if I close? Can you see? Can you see? Okay. Okay, so quickly I'm going to stop sharing and I'm going to share something else just to help us understand in bar charts why are we advised to use we're not advised to use mean. better to use counts and proportion than mean. So let us look into this quick exercise. Great. Can you say something? Okay, yeah. Great. So I want to believe we can all see this. It's a practical example. And I'll go through it fast. Can we please go through it together? So imagine 3 health facilities all report a mean waiting time of 4.8 hours. A bar chart would show 3 identical bars, so the leader will conclude these facilities perform the same. I'll go back. We see we have 3 facilities, facility A, facility B, facility C. And the mean is 4.8 for both. So when you use a bar chart in this case, it will all represent or show the same thing. So facility A is consistent and predictable. Yeah, we can see that because we have 4.5, 4.7, 0.9, 0.8. Facility B has 2 groups of patients, some waiting very little, others waiting very long, as we can see. We also have cases of 9.1 hours. Facility C has a serious crisis hidden inside that average. So some patients waiting nearly 15 hours, this 14.2. But at the end, they all give us the mean of 4.8. So the bar chart shows none of this when you use a bar chart. It will not show this. It doesn't show the teeny gritty details. These identical bars, 3 complete different realities. See? So just to cement on this, in such cases, you'll see that using a box plot, it's much advisable than using a bar chart, especially on mean. I don't know if we're together in that case.
Yes, I think that's a very valid thing.
Thanks. So let's go quickly to this second quiz. All this is to help to understand which chart to use when reporting our results. So a program report uses this chart to argue that Dar es Salaam has a dramatically higher malaria burden than other districts and needs urgent resources. We can see there Dar es Salaam, Dodoma, Mwanza, and there. What is the most important problem with this chart? A, wrong chart type. It should have been a box plot. B, y-axis does not start at 0. Differences are exaggerated. C, no sample size shown on the chart. And D, bar chart shows means variability is hidden. So you think, what is the problem? What really is the problem with that chart?
Annabelle says the bar chart shows means variability is hidden.
Thanks, Annabelle. Someone else? Yep, someone else? A different answer?
Kaiser
I would
says-
also say option B is also valid.
Okay. Kaiser and Victor also say B. The y-axis doesn't start at 0 differences.
Even to a great extent, option A is also valid. As personally, as far as I'm concerned.
Thank you. Thank you. Thank you. All answers are correct. However, in this context, I want to emphasize on this point on y-axis does not start at 0. So sometimes you might note these differences and you might think it's a very big problem. But when you go back and start these values at 0, you understand that it's likely there is no any significant differences between the charts. So
we're seeing your slides in presentation. The notes are showing.
Sorry?
The notes are showing.
No, what are you saying what I did? Mm, mm. How to put it in presentation mode?
It is true.
It's in presentation
Yeah.
mode already. Ah, okay.
Yeah.
Yeah. So let's proceed. So the y-axis does not start at 0, and that was a problem because when the y-axis does not start at 0, it gives you a picture that there is a very big variability between the values. But again, when you start at 0, you see that it's not significant. The districts are actually very similar, the range is only 5.1 units. So I think that will help us to understand that always our axis should start at 0. Is there any question? So let's go to the part of interpreting basic inferential statistics in public health. And in this context, we are going to look at the confidence interval, the p-values, the statistical with practical significance, and any common statistical misinterpretation. So we have spent time describing data, summarizing it, and visualizing it. Now we are going to a most important part on how we can conclude from what we have seen. So usually we take a sample from a population. You have your big population, you take a sample, and you do all these tests. Now, once you get the results, you want now to infer to the whole population. So when we come to inferential statistics, like, are you confident that the results that you have gotten can be inferred to the whole population? Inferential statistics, it makes a leap from what you have studied in the sample to what you're going to infer in the whole population that you have. So we cannot measure everyone in a population. We collect data from a sample and we use it to draw conclusions. And then what we have studied from a sample will help us guide us to inform the whole population. Now, the context of inferential statistics is what you have got. Are you confident with it? Are you sure with it that it can reference the whole population? Now, confidence interval, it shows us a range of values that likely contain the true population, From our example there, we have 95% confidence interval, example malaria prevalence. We have effect, it's 18%, and the confidence interval is from 14 to 22%. So what does it tell us? It tells us that if we repeated this study 100 times, 95% of confidence interval would capture the true value. I will repeat. The 95 confidence interval tells us that, remember, this is our sample. So if we repeat, if we do again, okay, we've done the first time, we've got 18%, and that is the range. You are doing this again for the second time, for the third time, for the 100th time. 95 times of the confidence intervals that you will get would capture the true value, that represents the population. So the narrow confidence interval, it's more precise estimate, and usually it includes the larger sample. And a wide confidence interval, when you get a very wide confidence interval, that is less certainty, and you have to be cautious about your conclusions. So let's look at this. Same study, different sample sizes. We have study A, study B, and study C. Study A, they recruited 300, is it 300? I think it's kind of 30. They recruited 30 observations and they got a confidence interval of 22 to 62%. It's very low precision, cannot make confident decisions. Sorry, can I rephrase that? Cannot make confident decisions. I was looking at the confidence interval. It ranges from 22 to 62%. And we can also look at the sample size, which I cannot see. And we also have study B. Study B, we have 120 observations. The confidence interval ranges from 36 to 50. And we have study C, which it has 800 number of observations. And you can look at the confidence interval. It's a little bit narrower as compared to the rest. So a very narrow confidence, it gives you high precision. It's very important to catch that. Confident estimate for policy decisions. So confidence interval, it always goes to the number of your sample size. When your sample size is large and when your sample size is small. We'll see on examples into that, unless there's a different question. The probability of getting these results by chance, if there was no real effect, that is a p-value. We are used to interpreting p-value that when it is less than 0.05, that is significant, and we go out very happy and we think that's done. But it's not only that. There are other pillars that you have to look apart from the p-value less than 0.05. So we know that if it is less than 0.01, that is a very strong evidence. And when the p-value is greater than 0.10, we say that it is not significant. Now let us look onto the public health example. So new malaria drugs with standard of care. You have a p-value of 0.03, which is statistically significant on a threshold of 0.05. So it tells us that only 3% chance this is due to chance. Now the common mistake here is P of less than 0.05 does not mean the effect is large or important. As I said, this is not the only pillar that you are looking at. It only means it is unlikely to be due to chance. So I'll always go back to the definition of the probability of getting these results by chance if there was no real effect. Is there a question? When the hypothesis is null, the probability of getting those results. Let's go to an example. Okay, let's look into statistical versus practical significance. Excuse me. So there are these two different contexts. We have statistical significance, we have practical significance. So is the result unlikely by chance? In case of statistical significance, we question ourselves, is the result unlikely by chance? We look at the p-value measured by the p-value. We look at the influence by the sample size. Can it be significant with tiny effects if sample is large? But when we go to practical significance, we ask, is the effect large enough to matter? We look at the measure of effect size. We are not covering that, the risk ratios in this context, but we'll also look at the based on real world context, and we're looking if it will guide policies. Yeah, so let us look into that small example. Example, a drug reduces fever by 0.1 degrees centigrade. And the p-value is very significant, 0.001. So you might go out shouting that the results that you found, they are significant, but is it practical? It's just a reduction of 0.1 degrees centigrade. So this is what we mean by statistical significance and practical significance. It can be very well statistically significant, but clinically it is meaningless. The effect is very small. So this is what I'm trying to emphasize. We are not only looking at the p-value, but we are also looking at the effect size. What is the effect size? Is it tangible enough to convince the policymakers to either change policy or enact their intervention and things? So before that, can we discuss this to help us understand what we have just learned? So it's a clustered randomized control trial across 40 facilities in Tanzania. It shows that controls, they have 58.3 hospitalization per 1,000 under 5, and the intervention is 51.7 per 1,000. The absolute reduction is 6.6 per 1,000. The relative reduction is 11.3%. And the p-value is 0.048, and we have a 95% confidence interval. Duration is 12 months. So the program team recommends immediate national scale-up, and you are the statistician in the room. The program team recommends immediate national, and you are the statistician. What are you going to do? Question number 1. The p-value is 0.048. The team says it is significant. What do you add to make this complete statement? Is it enough time to discuss numbers?
Is the question clear to everyone?
Or should we screenshot it and put it in groups and then we break them out in breaking rooms?
Yeah, we can do that. Yeah, so we can go and discuss this in the group. But before we go to the breakout rooms, I just wanted to make sure that everyone understands what the question actually is asking. Okay, so I'm taking the silence as the question is clear to everyone. Okay. We're gonna break you up into the breakout rooms. Look at this. Okay, I've just posted in the chat the actual question, so please download it before going into the breakout rooms because it won't be displayed on the screen when you are in the breakout rooms. And now I'm gonna create the breakout rooms. Okay, we'll use the same existing open rooms. And you have about 4-5 minutes to discuss this.
How do you unmute this?
Hey, guy, you are on mute. We can't hear anything.
Yeah, all this time we are talking. Oh, wow. Oh,
Hi.
let's unmute.
Yeah, sorry, our mic was on mute. And then we're having
Yeah,
a technical
yeah.
issue, but Christina should be online in a minute.
Yeah. So does anyone have a question from the slide that I just showed on the clarification of p-value? Have you unmuted already? Okay. If so, they won't have heard me because it wasn't mute.
Yeah, sorry, we were on mute for a little bit. But yeah, Christina is just gonna walk you through again.
Yeah.
And she's able to connect. Yeah, give us a minute.
Unable to join chat. Where is it unable to join chat? Yeah, we had a bit of a technical issue, but what I was previously saying, I was trying to emphasize on the p-value interpretation. So I'll take you quickly through it. A study evaluates a new community health worker malaria program across 60 facilities in Dodoma. The results show that malaria case rate reduced from 58 to 51 per thousand children under 5, with a p-value of 0.03. So in this context, what does a p-value 0.03 tell you? So A, it tells you a 3% chance the null hypothesis is true. B, it tells you that there is a 97% probability that the intervention works. C, it tells you that if there were truly no effect, results this extreme would occur only 3% of the time by chance. And D, the intervention reduced malaria cases significantly. It should be scaled out. So I was saying in this context, what the p-value really means, it's on C. If there were truly no effect between the two main variables, that means that the result this extreme would occur only 3% of the time by chance. So in this 8 minutes, let me take you through the common statistical misinterpretations in health research. The first misinterpretation is on correlation and causation. So correlation simply means the two variables, they move together, does not explain why. So once the variables correlate, we usually say that, or we usually mistake that they cause the other variable, but technically it's not causality, it's just a correlation. Example, let us look onto this example. Ice cream sales and drowning death are correlated. In this context, we mean in the seasons when the ice cream sales are high, maybe in the hot seasons, you'll find even the drowning death are increased because a lot of people go to swim. So all these two variables, they raise in that season, and you cannot conclude it by saying that maybe ice cream has caused the drowning event. They're just correlated, but you cannot form a causality in this context because both are caused by hot weather. We can look onto the public health example. Example, mosquito nets are correlated with lower malaria cases, but we still need a randomized control trial or strong study to design to confirm this. In order for you to confirm a causality, you have to run a particular study to confirm that, either it's a RCT or any study design. But just because variables are related, you cannot confirm by saying that one variable has caused the effect of the other variable. There is also concepts of confounders, which are not covered in this context. The other misinterpretation is over-interpretation of p-value. So in reality, p-value, it only shows the result is unlikely by chance. It shows that the absence of evidence is not equal to evidence of absence. This reflects the question that I just showed you, the example that I showed you previously. A p-value says nothing about how big the effect is. It uses effect size. So when you're reporting this, findings and you kept a p-value, you also have to put the effect size. We want to know how large is the effect. How large is the effect? Maybe it's 0.001. So the effect size is too small to practically implement any policy or any intervention. So p-value says something about how big the effect is. You have to use effect sizes. And the 0.05 threshold is arbitrary. It treats it as a guide. It's not a verdict. In some other studies, they use p-value of less than 0.0 or 1. And in those cases, when the studies are not very accurate, but in very delicate studies, example, clinical trials, the threshold is very low to 0.01. But in normal convention, they've kept the threshold of 0.05. So as I've said, it's not a verdict. And the other concept is the misuse of averages, as we have seen in many examples before. Mean is very sensitive to outliers. We should always move noting that in our head. You take your data, you summarize it, you look the distribution. If it is skewed, stick to media, stick to interquartile range. If it is normally distributed, symmetrical, then you'll use your mean, you'll use your standard deviation. And we know that the mode shows the frequencies. So back to our exercise. This was supposed to be a take-home exercise, but I'm going to pass through it up, and then I will leave on to you to discuss, and then you'll give me the right answers as Nema will tell you before Friday. So a program team recommends immediate national scale-up. You as a statistician in the room, you have a p-value of 0.048. The team says it is significant. What do you add to make this complete statement? So I'll just give you a hint. In this context, we not only look at the p-value. P-value, it's not only the lead that will guide us to change either policy or to do anything. You have to go back and look onto the confidence interval. You have to go back and look at the effect size. So you have to measure all these things before you infer these results to the whole population. In our context, they say the confidence interval is 0.3 to 12.9. What does this width tell you? The team leads with the relative reduction of that one. What will you present instead and why? Let me leave you this as a homework, but please take it in mind that in such context, p-value alone is not enough to infer your results to the whole population. You have to go back and look at the effect size. You have to go back and look at the confidence interval. If all this gives you the justification, then you can scale out your results to infer the whole population. Unless there is any question, I'll leave this to Neema.
Yeah, thank you. Thank you, Christina. I hope this was helpful for everyone, including people maybe that have a bit more background in statistics. And so, yeah, as Christina mentioned, this last exercise will be a homework assignment. And I've just pasted in the chat the groups that you will work on. So the assignment can be submitted on Google Classroom, and I'm just going to quickly show you where you will be able to find it. Oh, Christina, if you could please stop sharing.
Yeah.
Yeah, I think everyone can see my screen. The people online. Can I
Yes,
get a
of course.
Yeah,
Yes.
thank you, Vic. So when you go into the classroom, the first page that opens up here is this that says the stream tab. And here you'll see the different assignments and announcements as well. So for example, whenever we do post out the workshop surveys, either the pre or post, this is where they will appear. And if you go into this tab here that says classwork, this is where you'll see the different modules. So for the workshop that have already been covered, there are course materials that are uploaded. So under course materials, you'll find the PowerPoint slides that were used in that workshop, as well as the video recording from that session. So for the assignment that Christina gave you guys, that will be posted here under the foundational statistics for public health. And the deadline for submitting this will be on Friday, midnight, East African time. Because you'll be working in groups, one member from your group will be responsible for submitting the responses. So we expect to receive one responses for each group. Is that clear? And can everyone access the Google Classroom as well as see what I just showed you guys? Yeah, okay, thank you, Witty, for that confirmation. So Annabelle and Dawoodi, I think you're the only ones that haven't joined the class yet. I'm gonna reshare separately via chat the link to this so that you guys can also join and you can access all of these resources. Yeah, so we have reached the end of our workshop. Thank you so much, everyone, for joining. I hope this was helpful for everyone. I will be sending out the post-workshop survey as well. If you could please fill those out timely, that would be very helpful. We'd really love to hear your feedback. And if there are any questions, you can always reach out to us via the group WhatsApp. But otherwise, yeah, thank you, everyone. Enjoy the rest of your week, and we'll see you guys next week.
Thank you.
Bye, everyone.